Hi everyone, thank you for signing on to view tonight's homework video. You will need your lesson worksheet that you picked up today in class, lesson number 6, so that you can show all of your work as you complete these practice problems. Please feel free to pause the video at any time if you need to take your time to copy the notes. By the end of this lesson, we will be able to add and subtract polynomials. We will use the distributive property to separate terms that are grouped together. We will then search for like terms to combine so that we can rewrite an equivalent expression. What do I need to know? Well, first, you need to know what terms are. We discussed these last week in class, but as a reminder, a term can be either a number, such as 10, could be just a variable, such as n, or it could be a product or quotient of a combination of the two, numbers and variables. Product meaning that we see multiplication attaching the numbers and variables, and quotient meaning that we could see division attaching the numbers and variables. Here are some additional examples. Now, you can see here 5 and y show a product between a number and variable, whereas this example over here, 7 and x, show the quotient between the two. Each and every single one of these 5 examples demonstrates only one single term. They are not separated by addition or subtraction, which would separate terms. Like terms. Today's focus is finding like terms. These are terms that have the same variables with the same exponents. The coefficients may be different. Let's take a look at some of those examples. You can see here that x and x are the same variable and they both have an exponent of 1. Therefore 6x and negative 3x are considered like terms. You can see that y squared and y squared have the same base paired with the same exponent. So negative 2y squared and 5y squared are like terms. Even if we have a combination of variables, as long as each variable itself, x and x here, have the same exponent, and then separately y to the first and y to the first have the same exponent. So these are still another example of like terms. Okay, so now let's start with adding polynomials. There are 2 steps. The first step is to break out of the parentheses. Parentheses group terms together. We cannot combine any like terms until they are not grouped any longer. So after breaking them out of parentheses by distributing, step 2 is to combine like terms. Combining like terms can be shortened or abbreviated to CLT. Let's look at the first example. Right away I spot that 5r cubed and 6r cubed have common variables with the same exponent. However, I cannot combine them yet because 5r cubed is grouped by these parentheses with the 8, and 6r cubed is separately grouped by parentheses with this 3. To break them out, we can write in what's in front. Technically there's a 1 here. If I distribute this 1 to lose the parentheses, I still have 5r cubed. If I distribute this 1 to the 8, I still have positive 8. I can do the same here. If I have a 1, which is positive 1, times 6r cubed, it is 6r cubed, and 1 times 3 remains 3. Now we can search for like terms. I like to group my like terms using shapes. My 5r cubed and my 6r cubed can now be combined. If I have 5 of them plus 6 more, I now have 11r cubed. This positive 8 has a common term with positive 3. 8 plus 3 is 11. Because 11r cubed does not have any other like terms, and 11 has no other like terms, I cannot combine these, and this is considered my final answer in simplest form. It's also important that we write our answers in standard form. Standard form states that each answer should be written with terms in order, beginning with the highest exponent to the lowest. Constants are always written last. The constant is always the number without a variable. Here I can see that this r cubed term came first, and the last term was the constant. Let's take a look at example 2. In front of the set of parentheses, we can place the 1 again. If I distribute 1, I end up with 5. 1 times negative 3t stays negative 3t, and 1 times negative t squared is still negative t squared. I have to break this binomial out. In front of this set of parentheses is a positive 1 again. It does remain the same, plus 9t plus 4t squared. But now all of these terms are free to be combined with any other like terms. Okay, if I go in order from left to right, I see I have 5. Are there any other constants? No, so I still have 5. Now, I can look at negative 3t. Be sure when you put your shape around the term to include the sign in front of it. So I have negative 3t and positive 9t. These combine to give me positive 6t. Last, I have negative t squared and positive 4t squared. This negative 1t squared plus 4t squared becomes positive 3t squared. T and t squared do not have the same exponent, so I no longer have any like terms. This would be my final answer. However, if I want to worry about standard form, I have to rewrite it in the correct order. The term with the highest exponent goes first. 3t squared has the highest exponent. Remember, it does not matter about coefficient. And then 6t, and then 5 goes at the end because it is a constant. This would be my final answer for number 2. Pause the video here, try this problem on your own, and then press play and check your answer. Okay, we can see here that if I distribute this 1, I get 3p. Distribute it again, I get 1. Here, there's a positive 6 to distribute. If you distribute positive 6, you'll end up with 6p. Distribute positive 6 to negative 8, we multiply and get negative 48. In front of this set, we have a 1, which remains still p plus 2. If I combine 3p and 6p, that is 9p, plus 1 more gives me 10. Next we have 1 minus 48 is negative 47, but add 2, we get negative 45. This is my final answer in standard form. Let's move on to subtracting polynomials. The reason I teach distributing that 1 in front of the parentheses, although it seems a little tedious, is because then the rules stay the same for adding and subtracting. I still want to break out, but this time we have to look out for a negative 1 to distribute. And then we can combine like terms. So how is this different than before? Only slightly. In front of this group, to break it out, there's still a positive 1. I distribute and get x squared minus 2. In front of this set, however, we have a negative 1 to distribute. This negative 1 times 3x changes this to negative 3x. This negative 1 times positive 5 changes it to negative 5. Some have learned this previously as adding the opposite or keep, change, change. Now I can look for like terms. X squared does not have any like terms. It remains x squared. Negative 2 will combine with negative 5. I now have negative 7, and then minus 3x remains the same. However, we want to rearrange our answer into standard form, which is x squared minus 3x and 7 at the end, negative 7. Let's take a look at number 2. If I distribute the 1, it remains 3x cubed minus x squared plus 8. However, if I distribute the negative 1, every single term will change to its opposite sign. Negative x cubed, this will distribute. Negative 1 times positive 5 becomes negative 5x squared, becomes negative 4x, and then a negative times a negative 7 becomes a positive 7. Now let's look for like terms. To save some time, you can begin by looking for like terms of the highest exponent. That way we don't have to rewrite our answers in the end. So I have my highest exponent is x cubed. 3x cubed minus 1x cubed is 2x cubed. I then have negative x squared minus 5 more x squared. So negative 1 minus 5 more is negative 6x squared. We then have 8, but look, here's an x term, so I'm going to place negative 4x here before combining 8 and 7 to get 15. Now I don't have to rewrite my answer, it's already in standard form. Highest exponent down to the constant. Again, pause here, try it on your own, and then press play to check. See if you can get the correct answer on your own. Okay, check your answer. Let's see if you distribute the positive 1. These two terms should remain the same, x cubed plus 8x. But here, I changed it. We're going to distribute negative 2 to become negative 2x cubed. And a negative times a positive is negative 24x. Last step, combine like terms. Highest exponents first. 1 minus 2 is negative 1x cubed. And then 8x minus 24x leaves us with a negative 16x. One more way to present the question. In words, I ask you to subtract this trinomial from the second trinomial listed. It's important that we understand how to translate this into a mathematical sentence. There are two things I'd like you to remember. From is always written first. This trinomial is going to be written first. If I said subtract 5 from 10, you would think, so 5 from 10, you would think 10 minus 5. Same idea. From goes first. But you also want to use parentheses. So I am going to rewrite this trinomial first, negative a squared plus a minus 1, and we will subtract this trinomial like we were asked to. In parentheses, a cubed minus 2a squared plus 10. If you do not use parentheses, you will miss that we have to distribute this negative 1 before combining like terms, and we will not receive the same answer. So let's break these guys out so that we can combine like terms. If I distribute 1, these three terms will remain the same. So I'm going to break this trinomial out. Negative a squared plus a minus 1. These three terms will change to their opposites. Negative a cubed, positive 2a squared, and negative 10. Now we're ready to combine like terms. I look for my highest exponent. I find it here. There are no other a cubes. So my first term is negative a cubed. Next, I have negative a squared plus 2a squared. Negative 1 plus 2 is a positive 1a squared. I then have a. There are no like terms for a, so I have positive a. Negative 1 minus 10 more is negative 11. My final answer has 4 terms in standard form. We now know how to add and subtract polynomials. We had to use the distributive property to separate terms that were grouped together. This is our breaking out step. Break out. We then search to combine like terms. by finding common bases with the same exponent, and finally rewrote it as a simplified equivalent expression. Thank you for watching the video. You can always revisit this at a later time before your unit test.